Dear students, let me continue the next topic of the fourth module, that is user identification, process times and input output redirection. Three topics we are going to discuss in this video. So user identification, any process can find out its real and effective user ID and group ID. So any user who is working in Unix operating system, it can find out its effective user ID and group ID, real user ID and real group ID using some command. So sometimes, however, we want to find out login name of user who is running the program. So login name of the user you want to find out, because one user with can have many login names with the same user ID. So we could call get PWUID, get present working user ID, or get UID. We can call it to get the present working user ID. But what if a single user has multiple login names? If the single user has multiple login names and each with the same user ID. With the same user ID, a single user can create multiple logins. So the system normally keeps track of the names we log in, and the get login function provides a way to fetch that login name. The system normally keeps track of the name we log in. So every system in which Unix is running, it keeps a record of the login name with which we log in, and the get login function provides a way to fetch that login name. So get login function is used to fetch that login. For example, here cat star get login void, and it is defined in the unistd.h header file, so we have included it here. So all I want to say that user ID and group user ID can be retrieved for any user using the get PWUID or get UID, and login name can be retrieved using the function get login, star get login. Next topic is the process times. So there are three types of times that we can measure in the system. One is called wall clock time, another is user CPU time, and third one is system CPU time. What is wall clock time? It is the actual time taken from the start of computer program to the end. Whenever we start the computer till the end of the computer, whatever time is elapsed, that is called wall clock time. And in other words, it is the difference between the time at which a task finishes and the time at which the task is started. That is called wall clock time. Similarly, next is user CPU time. What is user CPU time? It is time spent on the processor running your program's code. So as you know that whenever we write a program, that program will run on processor only. So the total time spent on the processor running our program code is called user CPU time. System CPU time is the time spent running code in the operating system kernel on behalf of your program. System CPU time is the time spent running code. System CPU time is the time spent running code in the operating system. So Code will also run on the operating system. So the total time spent by running code on the operating system kernel is called the system CPU time. Any process can call the times function to obtain these values for itself and any terminated children. So how we can find out these times? So we can call a function clock underscore t times instruct tms star buffer hash include sys bar times dot h, and it returns the elapsed wall clock time in the clock ticks if OK minus 1 on error. What is wall clock time? The time when the system starts till the end. It's shut down. That is called wall clock time. So this function it returns the wall clock time in the form of tick. So what one argument we have passed here is TMS buffer. So what is TMS? TMS is the structure which has four different values: clock underscore t, TMS u time, clock underscore t, TMS s time, clock underscore t, cut cu time, and clock underscore t, TMS ch time. So here TMS u time is the user CPU time, TMS s time is the system CPU time, TMS underscore cu time is user CPU time or terminated children, and TMS underscore CS time is the system CPU time, and that is the terminated children. So all the information we can get it using the function called clock underscore t times. Next one is input output redirection. So what is input output redirection? There are always there are three default files: open, std in, that is a standard input file that is called keyboard, standard output file that is called screen, and standard error that is error message output to the screen. So these are the three different files are there. So these and any other file, open files, can be redirected. So these files, contents of any command can be redirected other than these three output or input. So redirection simply means capturing output from a file, command, program, script, or even code block within a script and sending it as input to another file, command, program, or script. Means we are taking the input from a file, command, program, script, or even code block, and we are redirecting to some another file, command, or program, or script. So this is called redirect. For example, say if we are here putting the command ls minus al. So ls minus al, what it will display? It will display all the files present in the present working directory. Now it will display on the output screen, the standard output. But since you have redirected using the angular bracket, so ls minus al, output of ls minus al will be redirected to the file listings. If you want to see the listing, you can use the cat command, cat listings, and whatever output of ls minus al is there, that you can see here. So total 324 and different files are. So this is called output redirection. Next one here, it is a input redirection. Suppose we have a command cat sample. In the sample, we have a line hang on for the best Linux session. Then we are